All right, welcome to Back to School Night 2021 here at Akalani's. My name is Dan Appel. I'm going to talk about physics of the universe. This is my second year teaching this course. It's the second year it's been offered here at Akalani's High School. In terms of our progression at Akalani's High School, this is our NGSS curriculum progression, where we have Living Earth as freshmen, chemistry and earth systems, and then physics of the universe. So this is our third course in the NGSS sequence that students can take. So when we're looking at physics of the universe, what is this class about? Well, it's designed to be a broad-based course where we talk about a lot of different topics. Really what it's looking at, though, is how does physics, these physical processes that students may or may not be familiar with, how do they govern the universe from the very, very small to the very, very large? So we study matter, forces, interactions, and we also look at some engineering practices. How can we use the techniques and tools that engineers use to solve kind of these real world problems? So the kind of three dimensions that this focuses on is what engineers do, what they know, and then how they think. How do they approach a problem? How do they break it apart into its component parts? And how do they apply the science behind it to get their solutions? So there are cross-cutting concepts that we see in the NGSS curriculum. We talk about all of these at different times during the year. We really look at scale, proportion, and quantity. We go from the size of an atom to the size of the universe, and so everything in between. So scale is very important in physics of the universe. We also look at energy. We look at energy from kind of fundamental what is energy? How do we calculate it? To energy systems. How do we produce energy? How do we use the forces of nature to actually create energy that people can use for their everyday occurrences? From some of our engineering practices that kind of carry through as well, students will be asking a lot of questions. Physics is a great course for asking questions because you can see all of those components. It's something that they're familiar with. They will be using mathematics to actually quantify and evaluate claims that they can kind of see in the everyday world. So they're going to cover these in different units. As it's a new course, the units might shift in terms of when they see them. We've made some adjustments for distance learning this year in terms of the order of the units, with the hope that if and when we are back in the classroom, we can expand some of the hands-on components of these units. And so this may or may not be the structure, but this is the topics that we will touch on in a year. So we start off with motion and forces. Students will look at Newton's laws of motion. They'll understand elementary force diagrams and be able to solve problems involving forces. They then transition into momentum and collisions. And then we look at forces at a distance. So we look at the force of gravity, we look at electrostatic forces, and students will be able to understand the similarities and differences between those types of forces. And then we look at energy. So we quantify energy, we look at energy calculations, and we look at different energy systems and evaluate them. In the second unit, we have electricity and magnetism, where students will build simple electric circuits. They'll look at the interaction and interplay between electricity and magnetism. We'll then do a process on nuclear processes, where we have a unit where we look at how do we produce these different atoms. What's the progression? How is nuclear energy produced? What does it do? We then get into waves. This is one of our biggest units, where students will look at classical waves, and then they'll get all the way down into light, looking at the electromagnetic spectrum and analyzing the different types of waves along that spectrum. And then our final unit is the stars in the universe, taking all of these different ideas, putting them together, looking way back at the idea of the Big Bang Theory. How did the universe come to be? What is the universe composed of? And how is the universe actively changing? In terms of our general week, we try to have a strong weekly structure. During a week, students will see some direct instruction. That could be a pre-recorded video in distance learning. It could be a lesson that's directed at the front of the class with the teacher, where the students are engaged in note-taking. We have lots of demonstrations. We will show students this in action. So we'll show them what this looks like, and it's a great course for having hands-on demonstrations that students will see. Students will be asked to investigate. They'll be given a question, and then they will come up with protocols and a process to be able to understand better that that concept that's being presented. We have lots of hands-on labs. For distance learning, we've transitioned some of those to be virtual labs, but we have lots of manipulatives and equipment that students will be able to use to complete their labs. And then we have weekly problem sets. So students will take those ideas and abstract them, solve theoretical problems, look through calculations, and be able to understand what those how their concepts are going to apply to their problem sets. And then we try to have lots of group work. This is a course that is modeled after a collaborative nature. Students are encouraged to work with others and to help each other out. They're going to learn a lot of science and engineering by talking things through and hearing what other people have to say about those components. All right, in terms of the expectations before you sign up, you should take the chemistry before taking this class. That will really help with some components. We are an algebra-based physics course, so you do not have to have calculus. Most students will have been through Algebra 2 when the time they take this class. It is not a math-heavy physics course, but there's definitely mathematics that are involved as students progress through the course. All right. That's it. Hopefully you have a better understanding of what the course is about. But if you need other resources, you can look at the full scope of the course content through the district website. Thank you.